You may remember that we actually discussed the internet in quite a bit of detail. But did you even realize how it all works, how it's put together? This is the job of, wait for it, the Internet Protocol. Currently there are two versions of the Internet Protocol, which we abbreviate IP. There's IP version 4, which is the most popular and currently in use. And then there's IP version 6, which is designed to replace it. Now, there are a lot of other certifications and studies that you can take if you want to understand this in more detail. But what we're trying to do is just introduce you to the topic, not make you an expert. In all reality, the mechanics are fascinating to learn, and there's an incredible amount of capability of the Internet Protocol. Let's just take a few moments to examine some of these principles.
One of the things I want to say at the outset is there are two current versions of the Internet Protocol. The first is version 4, which is the current one in use, and then there's version 6, which is actually up and coming and is an improvement that will eventually replace the version 4 protocol. Now, the question that may be in your mind is, what happened to version 5? Well, version 5 was essentially just an experimental protocol, was never intended for production use, and so you don't ever need to worry about version 5. So let's dig a little bit into version 4. One thing to keep in mind is that the Internet Protocol is actually not one protocol by itself, but is actually a suite or a collection of protocols. The Internet Protocol itself has a certain job. Then there are a number of other protocols that carry on various functions in order for things to actually operate fairly efficiently. The Internet Protocol itself actually deals with addressing and routing, and we'll take a brief look at addressing in this lesson. You have TCP, or the Transmission Control Protocol. This is a connection-oriented transport protocol that actually carries data and makes sure that it is safely transmitted and things are sequenced correctly. Then you have UDP, or the User Datagram Protocol. This is connectionless, and it essentially sends data with the assumption that if there's a problem, the application itself will handle any data loss or retransmission. And then there are a variety of other protocols, applications, and services that are a part of the TCP IP protocol suite. Whenever you want to send a letter to a friend, many times you're going to write your address in what's called the return address area. This is the physical address of where you're sending the letter from. It could include a street number, a street name, a zip code, a province or state name, country, and so forth. And then in the main address column, you actually write where it's going. The name of the friend, street address, and so forth in the other way. So there's a starting address and an ending address on that particular envelope. IP version 4 addressing actually works very similarly, and we're going to talk about how these addresses work, but you can think of it as an address where things start and an intended address where things are supposed to end up. So let's just briefly look at IP version 4 addressing. Now, first, it's important to know sort of what the format of these numbers that you'll see. Typically, it's what's called a dotted decimal notation. For instance, 216.145.1.2 is something you're commonly going to see. Now, this is actually an IP version 4 header. I don't expect you to memorize this or know this, and it's not really something specifically that's going to be broken down at this level in the A+ PC hardware exam. It is, however, helpful if you want to go on to other certifications for networking, for example. Knowing some of these principles are actually going to be helpful. You notice in yellow we actually have the source and destination IP address here, and I've just supplied two made-up addresses that just kind of give you an idea of how this works. The 216.145.1.2 is actually where this particular packet is supposed to end up, and the 24.231.17.5 is where it begins from. Now, there's different ways that you're going to see IP version 4 addresses. And I'm just using the 216.145.1.2 address as just an example. Those all translate into specific binary numbers. There are usually 4 groups of 8 binary bits. You see how it breaks down. And these are sometimes called the octets. The 216 is octet 1, 145 is octet 2, and so forth and so on. And this is the basic way that you're going to see the address represented, particularly on the left. You're not usually going to see the binary at all. Now, there's different ways that addresses are notated or represented. So we have our address here again, and there's sometimes what's called a network portion and a node portion. You might have a particular zip code that you share with a lot of other people, and that, for instance, could be considered the network aspect of your address in a way. And then the host or node is going to be your street number and street address within that zip code area. So just a way of sort of understanding how these particular addresses are represented. So this is one way you'll see it. And then you sometimes will have what are called masks. And again, this isn't something you really need to know or understand, but just the network and node is really going to be the most helpful. So you see 255.255.255 tells you that that's the network portion of the address, and then where the 0 is, that's the node portion of the address. Very deep topic all by itself, but just wanted to give you sort of an idea of how addresses are going to be represented. You're either going to see something like 216.145.1.2 with 255.255.255.0, or you might see 216.145.1.2/24, which really means the same thing. Again, really beyond that, you don't really need to have that much concern with it, but just wanted to give you an opportunity to sort of see how all this fits together. IP version 4 addresses are categorized together in groups called classes. And so it's a good idea just to understand the basic classification of how some of these address classes work. And so let's just take a look at this. So here's a sample network, and you have a number of different types of address classes here. And we'll actually look at these, but you see the 10.0.0.0/8 is one class of network. The 192.168.1.2 or 3.0 is another class of network, and your 172.16.0.0 is another class of network. Again, this is just groups of addresses that are together in basically some logical type of subcategory. You can usually tell from the very first binary digits of an address what type of address it is. For instance, Class A addresses start with 0. You notice how you have 0.0.0.0.1 to 0.1.1.1.1.1. Basically, it's going to start with binary 0. In decimal, that's going to be between 1 and 127. And really, you're not even able to use 127 because 127.0.0.1 is a loopback address. So it's basically between 1 and 126. Class B addresses start with 10. And in decimal, it's going to be between 128 and 191. And then you have Class C addresses, which start with 11 in the binary. And this is going to be between 192 and 223. So 192.168.11 is a Class C type of address, because it goes between the range of 192 to 223. And these are just some good things to keep in mind as you deal with IP version 4 addressing. So just to summarize, the network portion of the Class A is small, the host portion is big. In Class B, they're equal, and in Class C, the network portion is bigger and the host is smaller. It just means that there are certain groups of addresses available for networks and hosts respectively. Again, this isn't really something I expect you to know in detail, but I think it's good to have at least a basic grasp of how these things fit together. The other thing to keep in mind with IP addressing is there are two general classifications of addresses. There's public addressing, which simply means it's routable on the public internet, and then there's private, which is not. And there are several ranges, 10.0.0.0 to 10.255.255.255 is the private address range. You'll usually see in home networks where you buy devices such as Linksys and all that, you'll see these types of addresses used. It's sometimes also called a /8 or 255.0.0.0. These are just some basic representations of this particular group of private addresses. Now in this particular illustration, the /8 or the 255.0.0.0 that's represented here is actually the subnet address. And if you remember from our discussion, this is a Class A address range. Next, you have the 172.16.0.0 to the 172.31.255.255, which is sometimes called a /12 or a 255.240.0.0. So anything between 172.16.0.0 and 172.31.255.255 is a Class B private address type. And then you have the Class C private address type, 192.168.0.0 to 192.168.255.255. And on most consumer type devices, you're going to see this almost universally. And this is a /16 or 255.255.0.0. So Class A, Class B, and Class C private addressing. The final topic we want to deal with in the lesson on TCP IP has to do with IP version 4 services. You can think of services as other protocols used within the IP protocol in order to be able to do different important functions. So let's just talk a little bit about how this all works. The first is what are called TCP and UDP ports. If you remember when we first started talking about the Internet Protocol, we talked about the Transmission Control Protocol, which is a connection-oriented protocol, and the User Datagram Protocol, which is connectionless. One is almost paranoid about making sure everything gets to its destination, and UDP essentially doesn't care. If you've ever watched television, whether it's cable television or over the air, or you've looked at the radio dial and you've tuned into different stations, then you kind of get an idea of how ports work. For instance, if you want to watch news, you're going to tune into a news station. If you want to watch cartoons, you'll turn into a station you know actually has cartoons. Or if you want to watch sports, you're going to tune into the sports channel. That's how ports work. They listen on specific ports because that's what's going to live there. For instance, it could be web traffic or mail traffic, just like we'll show right here. So you have some sort of a switch, and this is again a local area network. And port 80 is what the workstation on the left is requesting to the workstation on the right. It knows that it's listening for web traffic on port 80. This is the channel or frequency or whatever you want to call it. Mail, it knows to look and send to port 25 because that's what that workstation is going to be listening on for mail. It's not going to be looking for web traffic or anything else on port 25. It's only going to be expecting mail on that channel, so to speak. And then port 53 is DNS. And the great part is this is what's called multiplexing because it can be doing all of these at the same time. It doesn't have to do a web request and then stop, and then do a mail request and then stop, and then a DNS request and then stop. It can actually do them all at the very same time. And this is one of the important concepts, TCP and UDP ports. So let's actually talk about some of these applications and services that are used in the Internet Protocol. One is DHCP. DHCP is great because instead of actually stopping and having to manually address every single workstation, you can actually have a server just hand it out automatically. It's a really simple process we'll just step through. You have a server, a workstation, and a network infrastructure. And basically, the workstation sends out just a basic message to figure out if there's a DHCP server it can use. And the DHCP server says, yeah, I'm here and I can do that job for you. Think of it as calling in for pizza. You call up in pizza and ask if they deliver to your area. It's kind of a similar concept. Then once it knows that that server is there, it says, okay, great. Now that I know you can do this for me, please give me an address. And the server says, great, here's your address, and it can be an IP address, a mask, default gateway, DNS, and all these other sorts of settings. And this is going to happen in corporate networks. It'll happen in consumer networks. This is even how DSL and cable give the IP address to the end user. DHCP, Dynamic Host Configuration Protocol. Good to know, and almost certain that you probably have dealt with it in some form or fashion. Now, being as we're not dealing with networking as a complete topic, there's a lot of complexity to DHCP we're not dealing with here. You can have issues where the address wasn't assigned, where the acknowledgement wasn't received, and there are different parts of the process where things can go awry. Another thing to keep in mind is something called lease times. Now, when you want to lease a car or an apartment or a home, you'll actually sign a document saying that you will occupy it for this amount of time. And DHCP leases operate the same way. They're specified for the amount of time that that lease will be considered valid before it has to be renewed. So it's interesting when you actually look at your DHCP settings, you can actually see what the lease times are. Common ones are a day, although I've heard some as short as 30 minutes, which is incredibly short. But there are different aspects and times that you can associate with DHCP leases. DNS, or Domain Name Services, is actually the process of translating a domain name, such as www.trainsignal.com, into an actual IP address that's existing on a server on the internet. It's very similar to the way you use mail. For example, if you want to send a mail to a friend of yours, but you don't know what their actual address is, their physical address, you have to look it up some way. It could be a phone book, it could be a Rolodex, it could even be Google and Yahoo and various other means. When you try to find who they are, or rather where they are, you'll actually get the address, and then you can actually send whatever letter that you want to. That's exactly what DNS does. It essentially looks up the address of that particular domain name and then allows that message to be sent. And again, this is a fairly simple process. If, for instance, the workstation on the right wanted to ping the workstation on the left and it's using an actual host name, there's a DNS server. So it says, great, I need to know what IP address is for, and you can call it workstation.com. Then it says, okay, workstation.com is actually at this IP address, and then it can actually send this ping or echo signal directly. Now, when we say the words ping and echo in this particular sense, we're just talking about a specific type of message that is sent and received. So just think of message rather than these other more technical definitions. Another service is FTP. If you've ever downloaded any kind of file, you've used FTP. You just may not have realized it. So here you have the network infrastructure and a server that listens on ports 20 or 21. Remember, we talked about logical channels. And it can download from the server, which is what is called a download because it's coming down to the workstation. And you have uploads, which you're actually putting it in the FTP server. Then you have web. It's sometimes called HTTP or Hypertext Transfer Protocol. And whenever you browse to a web page, this is actually what's being used. This uses port 80 for non-secure traffic and port 443 for encrypted traffic. Same situation we talked about before with the network. You've got a server that's listening on port 80, and you send a request saying, I want to look at the page for such and such. And it says, great, I'm going to send it back to you, and then the browser displays the result. So web traffic. So we've talked about DNS, we've talked about FTP, we've talked about DHCP, TCP, UDP, and a whole other host of acronyms. But it's important just to be able to have a basic grasp for how the Internet Protocol does its job. Now, as we've discussed networking and TCP IP, we actually want to give you just a brief demo of some of the characteristics of the things that we've talked about. To begin with, in Windows, you actually use the command CMD or command COMMAND to get to a command prompt. And the screen will look a lot like this. Now, first, we talked about several different types of addressing. So first, we talked about the IP addressing. And the command to actually see the address that's on this particular machine right now is ipconfig. And here we can actually expand this just a little bit. But notice here, this is the IP address listed right here. 172.16.21.253. Now you'll also remember that 172.16 was one of the private address ranges. And there's actually a device that takes these addresses that are not routable on the internet and translates them into one or more addresses that are routable on the internet. And this happens to be a public library, but this is just an example. If we wanted to see more of what was actually a part of the configuration, you could do ipconfig/all. And this actually shows just about everything there is available regarding the IP addressing. The wireless LAN adapter is the thing we want to look at the most, but as we said before, here is our IP address, and we talked about masks, and this is all supplied by DHCP, which we also talked about. Now notice here, this is what our DHCP server is. It's another one of these addresses that we talked about. Remember DNS? DNS is taking domain names such as yahoo.com and actually translating them into IP addresses. And these are the servers that are being used. So this gives you just an idea a little bit about how all of this works. Now let's actually demonstrate DNS. So if we wanted to, for example, go to, let's do ping www.yahoo.com. Now watch what happens. The first thing is it actually translates it into this particular IP address. And then it sends the echo signals to and from. this particular address. So DNS translated yahoo.com into this address, and then these are the echo signals that went back and forth. This is just some of the basics of addressing. We also talked a little bit about MAC addressing and our networking, and this is the hardware address of the wireless adapter. And so that's something else that you could easily take note of. There are other commands, but I want to show you one other thing while we finish this demo. And you can actually find out a lot just simply by going to what's called a route server. In this particular, it's AT&T. It's a public route server, route server.ip.att.net. And it actually asks you to log in with this name, so we do that RVIEWS. Now if we wanted to do show IP route, which is just a command asking about all the networks it knows about, you could see all sorts of things here. And if you wanted to test how to get to something, like we could do ping www.yahoo.com. And again, this is how DNS translated it to this and then sent the signals. Now this is also interesting because this is beyond the scope of what we were discussing, but this is an IP version 6 address as well. So do show IPv6 route. You can see their IP version 6 address as well. So this is not designed to make you networking experts, to just give you a little flavor of what goes on in the whole networking environment and about IP version 4, version 6 addresses and so forth. Just a brief demo. Hope it was informative and fun. Thank you. So to summarize, let's just look at some terms. IP version 4. This is the Internet Protocol version 4, which is the current protocol in use in most networks and across the Internet. An octet is a set of 8 binary bits that comprise each portion of an IP version 4 address. And remember, 4 octets compose a complete address. We talked about private addressing. This is a reserved range of addresses not routable on the global Internet, designated for use within an organization or enterprise. And then DNS, or Domain Name System, an application layer utility that translates host names into their associated IP version 4 address. Now, just as we conclude, there's also IP version 6, certainly way beyond anything you need to be concerned about. Just realize that that's the up and coming version of the Internet Protocol that's already in limited use across the world.
Quite a bit of information to take in, don't you think? There's quite a bit of detail. And as I mentioned before, this is covered in a greater amount of depth in the Network Plus and certifications like the CCNA. So there's certainly much more that you can do. But this gives you an idea of the fundamental building blocks of the Internet Protocol, which I can guarantee you will interact with as a computing technical professional. Thanks for riding along.